Hi everyone, we're going to look at lesson 4.6. We're on page 210. So in this section what we're doing is we're looking at what's called an arithmetic sequence. And I know this word sounds or looks like arithmetic, and you're right, it is spelled the same way, but when we talk about it in a descriptive way, describing our sequence, we pronounce it as arithmetic sequence. So a sequence is an ordered list of numbers. Each number in the sequence is called a term. Each term, a sub n, so a sub n stands for the term number, has a specific position, n, in the sequence. So in this example here, we have 5, 10, 15, 20, 25. The first position, the first term would be 5. So this term's n would be 1. This term's n would be 2. This term's n would be 3. Each of these numbers stand for a sub n. So this would be a sub 1, this would be a sub 2, this would be a sub 3, a sub 4, a sub 5, and then a sub n stands for any number in any position, or the nth position. Excuse me, so when we talk about an arithmetic sequence, the difference between each pair of consecutive terms is the same. This difference is called a common difference. Each term is found by adding the common difference to the previous term. So this 5, 10, 15, 20, notice the pattern is that we're adding by 5 each time. That's an arithmetic sequence when you add by the same amount each time. The number that you add by is called the common difference. So let's write these ideas down just so that we have them. This is section 4.6. First is arithmetic sequence. And an arithmetic sequence is when the numbers in the sequence add by the same amount each time. Add by the same amount. Okay, this amount that we add by is called the common difference. And we're going to use the variable d to describe the common difference. So the common difference is the number that is added to get to the next term. Number added to get to the next term. Okay, so these are our 2 vocab terms so far here. Remember that our term number is going to be n, and our term value is a sub n. Okay, let's take a look at example 1. So in example 1, we have extending the arithmetic sequence. Write the next 3 terms in the arithmetic sequence. So we have negative 7, negative 14, negative 21, negative 28. We want to first find what are we adding by to get to the next term. So what they did was they organized the information in a table. The first term was negative 7, the second term was negative 14, and so on. And then you can look at the pattern in the table. So to get from negative 7 to negative 14, we're adding negative 7, or you can say subtracting 7, same thing. And then negative 14 to negative 21, we're adding negative 7. Negative 21 to negative 28, we're adding negative 7. So now if I want to find the next 3 terms in the pattern, I just want to keep this going. Let's find the next 3 terms. So we're going to add negative 7. So from negative 28, minus 7 would be negative 35. Minus 7 would be negative 42. Minus 7 is negative 49. And those are the next 3 terms. So that's pretty straightforward. That's example 1. Let's take a look at example 2. So in example 2, now we can graph the arithmetic sequence. In the arithmetic sequence, to graph it, the term's position, the n, is like the x value. And the term number, a sub n, is like the y value, and you plot it as an ordered pair, so it's like x and y would be n and a sub n. So let's look at this. Graph the arithmetic sequence 4, 8, 12, 16, and what do you notice? So we're gonna make a table. The first term is 4, the second term is 8, third term is 12, fourth term is 16, and then we plot those points on a coordinate plane. Here's 1, 4, here's 2, 8, here's 3, 12, here's 4, 16. What you should notice is that these points here are forming a line, or they lie on a line. And that makes sense because this is like a linear function, right? When you add by the same amount, this table has a constant rate of change, which makes it linear. So that's why these points form a line. Let's look at example 3. Identifying an arithmetic sequence from a graph. Does the graph represent an arithmetic sequence, and explain? So what we can do is we can take these points and put them into a table and see if it has a constant rate of change. So our x's were 1, 2, 3, and 4. Those were the x's, or the n's. And then our y's were 15, 12, 9, and 6, or the a sub n's. Those are them. And now let's look to see, does this have a constant rate of change? Yeah, this would be +1 for the x's, and then -3 for the y's. So yes, this would represent an arithmetic sequence. The consecutive terms have a common difference of -3. Let's take a look at example 4. So on this page, what we're going to do now is we're going to actually write an equation for an arithmetic sequence. So what this allows us to do is it allows us to find the term number for any term in the sequence, not just the first 4 or 5 or 10. Just by making a table, by looking at it, we can find the 100th term or the 50th term or the 300th term by writing an equation and being able to plug it in. So let's write this down in our notes. We're going to write our equation for the nth term. And again, n just stands for any term number. The formula that we're going to use is a sub n equals, so that's the term value, equals a sub 1. A sub 1, remember, is going to be the first term in the sequence, plus the quantity of n minus 1 times d. Remember that d, we already set up here, is the common difference. So the reason that we want to do n minus 1 is because we're following the pattern and we're starting at the first term instead of starting at the 0 term, and that's what happens. After we plug these numbers into the equation, we can always simplify the equation if we want to and get it into its simplest form. Let's look at the example and then we'll try some together. So in example 4, write an equation for the nth term of the arithmetic sequence 14, 11, 8, and 5. Then we'll find a sub 50. So we're going to use the formula. The first thing we need to know is a sub 1. What's the first term in the pattern? Well, in our pattern, the first term is 14. That's going to be our a sub 1. We're going to keep this n minus 1. That's part of our formula. Now we have to find the d, which is common difference. How do you get from 14 to 11 to 8 to 5? You minus 3 each time, so our common difference is -3, and that's going to go over here. Now we can simplify this equation. So if I simplify this equation, I would distribute this -3 into both of these here. If I distribute the -3, this would be -3n, and then this would become +3, and then I can combine the 14 and that +3 to give me 17. So this would be my equation if I simplified it. Our last step now for this problem is we're going to find a sub 50. So this 50 represents the n value. We're going to use the equation to find the 50th value. So instead of n, we're replacing it with 50. -3 times 50 plus 17 would be -133. Let's do 2 more like this. We're going to take a look at monitoring progress number 9. I'm going to write down the sequence just so I have it here on my paper. 8, 16, 24, 32. We're going to find the equation using this formula here that we wrote down before. A sub n equals a sub 1 times plus the quantity of n minus 1 times d. So the first thing that we need to do here is let's find a sub 1. A sub 1 is the first term in this pattern, which is 8. Next, let's find the d, which is common difference. How do I get from 8 to 16 to 24 to 32? I'm adding 8 each time, so that means our common difference is 8. Let's take these numbers and let's plug it into our equation. We're going to get a sub n equals, our a sub 1 is 8, plus the quantity of n minus 1, that just always stays the same, times our common difference, which is 8. Now we're going to simplify this equation. I'm going to distribute the 8 into the parentheses, and it doesn't matter that the 8 is behind the parentheses or if it was in front of the parentheses, you're still multiplying it, so we're still going to distribute it to the n minus 1. A sub n equals 8 plus 8n minus 8. Our next step is now let's combine our like terms. This 8 and minus 8 are going to be combined. Well, 8 minus 8 cancels out, and we're left with the equation a sub n equals 8n. Our next step now is we're going to find a sub 25. That's what it says here. Then find a sub 25. So when I find a sub 25, that means that I'm going to let n equal 25, and I'm going to plug it into my equation. A sub 25 equals 8 times 25. And now all I have to do is multiply these two numbers together. I can use my calculator if I want to. 8 times 25 is 200. So that would be the 25th term in the sequence. Let's do one more like this. We're going to look at number 10. 1, 0, negative 1, negative 2. Okay, we're going to start off the same way. Let's say our a sub 1, that's the first number in our pattern here in our sequence, is 1. D, which is the common difference. How do we get from 1 to 0 to negative 1 to negative 2? We're going down by 1, so minus 1. Our common difference is negative 1. Let's plug this into our formula and let's find our equation for the nth term. We have a sub n equals a sub 1 plus the quantity of n minus 1 times our common difference d. Let's simplify the equation. We're going to distribute negative 1 into the parentheses. A sub n equals 1, and then negative 1 times n would be minus n, or you can say minus 1n if you want. And then negative 1 times negative 1, that would be positive 1. Let's combine our like terms. Positive 1 and positive 1 makes 2. So a sub n equals negative n plus 2. And that would be our equation for the nth term. Let's do the second step. Now we're going to find, again, a sub 25. So that means we're going to plug in 25 for n. A sub 25 equals, this would be the opposite of 25 plus 2. This would give me negative 25 plus 2, which equals negative 23. And just like that, we found the 25th term.